Lakshmi Badrapur, and I am from Sri Siddheshwar Government First Grade College and PG Study Center, Nargund. Today I am here to deliver my seminar on topic of EMF of cell definition and its measurement by potentiometer, standard cell, Western standard cell, its construction and working. Let's start. EMF of the cell definition. The potential difference between two electrodes of a galvanic cell which causes a flow of electron is called electromotive force. Comparison of EMFs. Potentiometer can also be used for the comparison of two EMF sources. The balancing length of EMF E1 of a cell is found and compared with the balancing length of a standard cell, which is also found separately. If lambda and lambda1 are the two EMF sources null at lengths L and L1 respectively, then dividing the one equation by other. Internal resistance of a primary cell. Internal resistance is the resistance which is present within the battery that resists the current flow when connected to a circuit. Thus, it causes a voltage drop when current flows through it. It is the resistance provided by the electrolyte and electrolytes which present in cell. Relation between EMF, potential difference and internal resistance of a cell. If a cell of EMF E and internal resistance R connected to an external resistance R, then the circuit has the total resistance capital R plus R. The current I in the circuit is given by I is equal to E divided by capital R plus small r. Hence, V is equal to I capital R is equal to E minus I into R. This means V is less than E by an amount equal to the fall of potential inside the cell due to its internal resistance. From the above equation, T divided by R is equal to E minus V divided by V. Determination of internal resistance of a primary by potentiometer. Using potentiometer, we can adjust the rheostat to obtain the balancing lengths I1 and I2 of the potentiometer for open and closed circuits respectively. Then E is equal to K into L1 and V is equal to KL2, where K is the potential gradient along the wire. Now we can modify the equation for getting the internal resistance of the given cell by using the above relations as R is equal to capital R into L1 minus L2 divided by L2. The Western standard cell is an electrochemical cell that produces a stable and known electromotive force EMF, primarily used as a voltage reference in various electrical measurements. It consists of an H-shaped glass vessel with electrodes of cadmium amalgam and mercury, separated by a saturated solution of cadmium sulfate. The cell's working principle relies on the electrochemical reaction between cadmium and mercury, generating a constant voltage of approximately 1.0183 volts at 20 degrees Celsius. Here is a more detailed breakdown. Construction. H-shaped glass vessel. The cell is housed within an H-shaped glass container, ensuring separation of the electrodes and minimizing contact between them. Electrodes. Cadmium amalgam. The anode is made of a cadmium-mercury amalgam, typically sealed in a glass tube. Mercury. The cathode is a pure mercury topped with a paste of mercurous sulfate. Electrolyte. The electrolyte is a saturated solution of cadmium sulfate, ensuring constant concentration and stable EMF. Connections. Platinum wires are sealed into the glass tubes at the bottom, making a contact with the electrodes and allowing for external connections. Working principle. Anode reaction. At the cadmium amalgam anode, cadmium dissolving into the cadmium sulfate solution, releasing electrons. Cadmium solid, cadmium plus 2 plus aqueous plus 2 electron. Cathode reaction. At the mercury cathode, mercurous sulfate reduces the mercury and sulfate ions, taking the electrons. Stable EMF. The overall reaction involving the dissolution of cadmium and the formation of mercury and sulfate ions generates a constant EMF of approximately 1.0183 volts at 20 degrees Celsius. Temperature dependence. The cell's voltage has a slight temperature dependence, but it remains relatively stable compared to other electrochemical